Efficient, eco-friendly, sustainable Mediterranean greenhouse integrated with artificial intelligence, high-tech automation and control system. Susmedhouse project. The aim of the Susmedhouse project was to develop technologies, software and methodologies for a sustainable greenhouse system that enhance productivity and reduce resource consumption through artificial intelligence, along with innovative greenhouse applications. All developments demonstrated in the Susmedhouse demonstration greenhouse that have been built as part of the project's scope. After the simulation studies of the greenhouse design, including orientation and placement simulations of PV panels to maximize electric production efficiency and light homogeneity while minimizing the negative effects, mainly shadow from PV panels installment in the greenhouse, Susmedhouse demonstration greenhouse with a size of 2,000 meters square was constructed in Ankara, Turkey. This greenhouse has 4 different sections representing hydroponic, aquaponic, agro-photovoltaic, and conventional greenhouses. The subsystems developed by partners were integrated into the greenhouse once they were completed. Operational tests were conducted, and improvements and modifications were made throughout the demonstrations. The demonstration greenhouse includes a control and irrigation department, an office, and the boiler room. It is equipped with climate control, solar energy, and automated systems for irrigation and fertilization. Furthermore, the greenhouse features the heating system and the power supply generator to address power outages. LED lighting has been strategically installed in the demonstration greenhouse to assess and optimize the plant growth process using artificial light. It's worth noting that these LED lights are integrated with Internet of Things (IoT) technology and are controlled through a decision support system. In order to understand the needs of growers and the common requirements of greenhouse crops, interviews were conducted with greenhouse owners, technicians, and agricultural engineers. Furthermore, to gain insights into the current technological landscape in Mediterranean greenhouses, comprehensive literature reviews and on-site surveys were carried out. The knowledge acquired through these literature reviews, interviews, and surveys served as valuable input for the technical work packages of the Susmedhouse project. This, in turn, enabled the development of the most efficient, eco-friendly, sustainable, and socially accepted solutions for Mediterranean growers. To achieve this goal, visits were made to greenhouses in Turkey, Morocco, and Spain, where meaningful discussions were held with farmers and researchers actively engaged in this field. To develop artificial intelligence, AI, and decision support systems, DSS, more than 500,000 labeled images, including visual and numerical datasets for tomatoes, peppers, and lettuce, have been created and used in deep learning and optimization studies. The image processing and AI software comprise several machine and deep learning algorithms which have yielded promising results in detecting anomalies, monitoring and tracking pest populations inside the greenhouse, and providing the necessary information for the decision support system's harvest prediction function. The collected image datasets, in conjunction with the developed artificial intelligence algorithms and software, have been transformed into valuable assets that can be utilized in future projects and are also available for researchers and academics. AgriRobot has been developed to capture photos of greenhouse crops for analysis using our image processing and AI software. It efficiently sprays crops when anomalies are detected by the software. This AgriRobot is an innovative solution designed to identify pests, diseases, and apply plant treatments without human intervention. Although a prototype was built and presented to farmers, survey results revealed their lack of interest in the robot. Concerns include the cost and the potential transmission of viruses and bacteria by the robot. During greenhouse survey visits, the first concept of robot was discussed with the end users, and engineers agreed modifications of the existing vehicles in the greenhouse called cultural trolleys. This led to the idea of merging robot hardware and software with these vehicles. The result is a versatile robot usable in both automatic as robot for anomaly detection and spraying the manual modes for conventional plant cultural activities. The information collected through the collaboration between the robot and AI software is presented to users through a user-friendly interface in the decision support system, aiming to offer the best user experience. A comprehensive decision support system, DSS, has been developed for greenhouse farming, offering the following key features. User-friendly interface. The DSS provides an accessible platform with a user-friendly interface, available in desktop, web-based, and mobile app versions for flexibility. AI and machine learning insights for greenhouse farming. Leveraging machine learning algorithms, our system deciphers the complex interplay of environmental factors like temperature, humidity, pH, EC, and PAR in greenhouse farming. DSS brings innovative solutions to greenhouse farming, such as forecasting biological pest and pathogen control, linking environmental factors to plant growth and pest infestations. Data collection. The system collects data from greenhouse sensors including temperature, humidity, PAR, and lux values to provide detailed insights into the greenhouse condition. Disease and pest management. By monitoring and controlling greenhouse automation systems, the DSS effectively detects and manages diseases and pests using AI techniques. Incorporating advanced hyperspectral imaging combined with IR thermal sensors, our system offers non-invasive early detection of pests and anomalies. Convolutional Neural Network (CNN) model trained on over 3,000 images employs a tiling approach, refining pest segmentation across varying sizes, ensuring minimized crop damage. Early anomaly detection. Utilizing data from sensors and advanced image processing, the DSS can detect potential issues related to pests and diseases at an early stage, enabling proactive measures. Efficiency and enhancement. The DSS supports decision-making based on AI algorithms, enhancing overall efficiency and minimizing human-related issues within the greenhouse environment. Production optimization. Data analysis helps identify opportunities for improving production, enhancing quality, and maximizing profitability. Harvest estimation. The DSS accurately estimates harvest time, expected yield, and profits, enabling informed decisions regarding cultivation practices and resource allocation. Reduce pesticide usage. Early warning systems for disease and pest management lead to timely action, reducing the need for excessive pesticide usage. Advanced technologies. By combining advanced technologies such as AI, ML, and image processing, the DSS empowers farmers with valuable insights and efficient control over greenhouse operations. Incorporating predictive modeling, our methodologies harness the strengths of random forest, XGBoost, and both recurrent neural networks, RNN, and long short-term memory, LSTM models. These tools adaptively manage a blend of continuous and categorical data, providing accurate forecasts and pest infestations. With a focus on minimizing the mean absolute error, MAE, we ensure that our predictions remain optimized for actual greenhouse conditions. This comprehensive approach contributes to a 20% increase in productivity. An optimization algorithm based on particle swarm optimization was developed to find the ideal environmental conditions and best mixture, EC and pH values for tomatoes, lettuce, and peppers plant irrigation, aligning with the Susmedhouse project's innovations. This algorithm was integrated into Python-based optimization software. To streamline experiments, dedicated plant cultivation cabins were constructed in the AR&TeCS backyard. A precise control and automation system managed environmental conditions and plant irrigation within these cabins. Artificial lighting systems were tailored for optimal growth of each plant type. These experiments successfully identified the best conditions and fertigation strategies for each crop at various growth stages. These findings were then applied in the Susmedhouse demonstration greenhouse, marking a significant stride toward maximizing sustainability and resource efficiency in greenhouse cultivation, bolstering plant growth while minimizing resource consumption. Susmedhouse's disruptive biosense technology, developed by Vola, enables real-time, on-site analysis of water quality at a lower cost compared to current methods. It covers biochemical, biological, microbiological parameters and toxicity. This technology allows online monitoring, early warnings, and feedback through AI. Novel biosensors for various parameters have been developed, integrated into the ASIP system, and implemented in the Susmedhouse greenhouse. ASIP operates effectively, is user-friendly, and ensures reliable and repetitive analysis over time. Functional coatings. The idea was to develop two types of functional coatings for the plastic cover of the greenhouse's roof by Fraunhofer ISE. One type decreases the energy loss of the greenhouse during wintertime in cold regions, so-called winter coating. The other type of coating material limits the heat intake into the greenhouse in summer by cutting off the near-infrared portion of the solar radiation, which just heats up the greenhouse and damages the plants, so-called summer coating. The coatings were deposited by sputter deposition and tested in climate chamber and condensation tests and sent to Ankara to be integrated in the Susmedhouse demonstration greenhouse. 3 tunnel greenhouses have been constructed at AR&TeCS facilities, one with winter coating, one with summer coating, and one reference greenhouse with uncoated PET. In the second term of the project, the influence of the coatings on temperature and plant growth was studied for tomato, pepper, and lettuce, which were planted in different periods of the year. In the greenhouse with summer coating, the temperature inside the greenhouse was found to be 5 degrees Celsius cooler during the day than the other sections. The summer coating cuts too much PAR radiation and shows most of the time a negative effect on tomato plant growth, but it was better for lettuce. Additionally, we received some promising results with the winter coatings for the growth of tomatoes during spring and fall. The daylight simulations were conducted to analyze the shading ratios in the Susmedhouse for different photovoltaic integration scenarios. The sunlight requirements of the crops were prioritized for analyzing the light availability and homogeneity in the greenhouse. The idea was to utilize PV panels to reduce excessive heat and irradiation that are harmful for the plants and generate clean energy. Final design has been completed to be implemented in the Susmedhouse demonstration greenhouse. The results of the harvest period 2023 were promising for agro-PV applications on the greenhouse. The lab-scale production and study of 5 high-quality composts were carried out using a selection of organic waste, including tomato and pepper plant residues, by CNR by mixing the most promising composts with a selection of suitable zeolites, up to 8 innovative peat-free growing media that are zeocomposts were designed, analyzed, and verified in preliminary agronomic tests. The best performing zeocompost was produced in an on-farm compositing plant at Eboli located in Salerno, Italy. However, due to shipping issues and a lack of customs permission, the produced compost was not transported to Ankara. To address this challenge, compost was produced locally in Ankara under the supervision of CNR using waste from the demonstration greenhouse. Subsequently, a cultivation experiment was conducted using the locally produced compost. New eco-friendly methods to combat pests and pathogens, such as biological pest control, have been developed by AVIPE. This includes enhancements in spraying quality, which has been a significant challenge for growers. Sustainability has been assessed from social, environmental, and economic perspectives. Furthermore, business models and market analysis have been conducted to gain insights into the project's concept, economic viability, and market sustainability during the second half of the project. Project website incorporating an intranet as a project repository and a risk analysis tool has been created and updated by Proteus. Moreover, social media accounts on LinkedIn, Facebook, Twitter, and YouTube have been created and project news are being posted systematically. Posters, flyers, and newsletters that are downloadable from the website have been produced. Furthermore, videos for the project have been created and several workshops on business planning and modeling have been organized with all partners. Regarding coordination activities of the project, after a long delay to organize a face-to-face meeting due to COVID-19 pandemic situation, finally, the face-to-face meetings could be held. During the project, 4 face-to-face consortium meetings have been held, 2 in Turkey, Antalya and Ankara, and the others in Paris and Italy. These meetings provided an opportunity for partners to discuss and exchange views on the latest achievements and perspectives. The face-to-face meetings schedules included visits to the greenhouse and related facilities, as well as participation in exhibitions focusing on agricultural technologies and innovations. Additionally, some partners individually traveled to Ankara to see the demonstration greenhouse and to have on-site discussions regarding their work packages' relevant issues. Finally, the final public event with the presence of more than 50 participants, including Gölbaşı Governor, Deputy Mayor, the Prima Project Officer, 2 universities' deputy rectors, academicians and students, representatives from the Agricultural and Forestry Ministry, and companies specializing in the development of new technologies in agriculture, was hosted by AR&TeCS on 15th of June 2023 at AR&TeCS facilities, including Susmedhouse demonstration greenhouse in Ankara. The event was co-organized with Ankara University Technopolis Management to increase dissemination. During the event, representatives of the project partners and AR&TeCS engineers gave presentations on the successes of the Susmedhouse, and an open discussion and exchange of opinions were carried out at the end of the morning session. After having lunch with all participants hosted by AR&TeCS, Susmedhouse greenhouse was visited. Detailed information about each subsystem was given by the relevant project partners to the visitors.